So this is VP22, and we're going to use lists and dictionaries, which are extremely useful features in Python. So here's one-dimensional lists. Let me just print this down, run this, and we'll see how it looks. All right, so you make a list, you use square brackets, and you separate the elements with commas. So that's a list, and so if I print A and the type of A, this is A, and it is the type of variable it is a list. Then I can print A bracket 0. That's how you pick one element out of the list. That's going to be 1, which is an integer. You can then sort the list. There's a lot of things you can do with the list. One of the things you can do is sort it, and after sorting it, it puts it in order, of course, and it's still a list. And you can then append something to the end of it, 99. That'll add this number to the end. And you can also set as an item to a value. Lists are mutable. So if I want to change the first element in the list, which is 1, to 100, I can just set A sub 0 to 100. And now I have 100 here and 99 there, and the rest left over. Notice also here's how I chose to print it. This way I print for I in A, that's going to take each element in the list and print it, and after for the end of this, it's going to use a space instead of a carriage return, so I get this kind of printout instead of it being vertical. So those are good tricks that are handy to use. And by the way, lists do not have to be numerical. So I can have A sub 1, got to have square brackets, sub 1 equals fish. And it shouldn't complain about that. There. If I run this, there, it just puts fish there. It can put any kind of data in a list, a string as well as an integer, and other things as well, like another list. And that's what a two-dimensional list is. So here, let's try this one. All right, so I define three little lists, A, B, and C, and then I define D to be a list of lists, A, B, and C, and then I print them all out. So, well, just print out D. We know what A, B, and C look like. We're going to print out D. D is this. It's got two layers of brackets. The first element is a list, and so is the second and third element, and that's a list. D sub 0 is the first element, which is a list itself, and you can refer D sub 0 sub 1 to be the 0th element in the D list, and the first element in the list here, which is going to be 2. So this is how you make two-dimensional structures to represent things like a chessboard and things like that, which will be quite handy if you go ahead in the projects. All right, and similar to a list, but different, is a dictionary. This is a structure that lets you look up data from an index value. So the idea is you could define item number 1 is apple, 2 is baker, 3 is cat. So the first item is the index number, then there's a colon, then the value. So I can print out A, and then I can look at A sub 1, and I can set A sub 1 to alligator. So you'll see this thing is a list. It is a dictionary. A dictionary looks like a list. Two differences are it has curly braces instead of colons, curly braces instead of square brackets, and it has colons, pairs of data, index colon value here. So that's a dictionary. So A sub 1 is now apple. And this doesn't necessarily mean the first element in an ordered list. It means the value with index 1. For example, I could change this to 10 and then refer to it here as 10, and it would be fine. Let's just run that one. And down here I forgot I made a 1. And see, there's no longer any element number 1 because it looks for an index number 1. I have to be consistent and put it everywhere, and now I'm fine. All right, and now it's mutable too. You can change one element of a dictionary. You can change the index 10 to point to alligator, and it will make that change. All right. And those things turn out to be very useful. So here's you can find out how long it takes to search an unordered list. If you have a bunch of data, like passwords, that are just in no particular order, and you're searching for something, then I have a guess and it's going to guess a password. It's going to tell me how much time it took to hunt for something. So let me see how I wanted to do. Okay, I'm going to try these guesses, starting with 1, 2, 3, 4, 5, 6. So I'll run this, and so I'm going to guess 1, 2, 3, 4, 5, 6, enter, and it found it right away in 10 to the minus 6 seconds. If I do I love you and QQQ, let's try I love you. And that one, it took 6 times as long, 6 microseconds. And if I do QQQ, it's going to take 7 microseconds, which is, I think, how long it takes to hunt through the whole list and find out that something's not there. The point is, if your list has no order, then the only way to search it is to go one by one through all the items. And if I want to be sure that something is not included in the list, I wonder if there's any way to get this stupid thing to go away. Anyway, if I want to, then the only way to be sure something is not in the list is to try every item one by one, since it is not unordered. This is why sorting is such a big deal. Sorting makes things a lot better. Anyway, then there's some flags to find doing this. So you have a little bit of introduction to lists and dictionaries, and you can use them to hunt for things. So let me stop this recording.